Okay, this is number 2 on lesson 5.5 over trapezoidal rule. We're going to try to approximate this integral of x squared dx from 2 to 0 using the trapezoidal rule. So let's graph it first. So I'm going to make my equation I'm going to graph is y equals x squared, because x squared is my integrand. I'm going to use the numbers from 0 to 2, so let's go 0, 1, and 2. If you plug 0 in for x, 0 squared is 0, 1 squared is 1, 2 squared is 4. Let's sketch the graph. Something like this. So let's graph the point 0, 0, 1, 1, 2, 4. And I hope we know that y equals x squared is a parabola, right? So we're looking at the right half of a parabola, something like this. We're approximating this area under the curve using the trapezoidal rule. Does it say how many trapezoids we should use?
No. N equals 4.
It says n equals 4. That means they want 4 trapezoids. Okay? So actually, let's back up a second. If I need 4 trapezoids, I'm going to have to split this into 4 equal pieces here. So I'm going to have half. And 3 halves in here. And the way you can get the height of your trapezoid, in other words, the width on your actual picture, is you take b minus a divided by n. So in this case, the height of our trapezoid, b minus a would be 2 minus 0. b and a are your boundaries of your integral. So 2 minus 0 divided by the number of trapezoid, which is 4. So 2/4 or 1/2 is your height. In other words, each trapezoid is going to have a height which runs sideways of a half of a unit. So let's go back in here. Let me rewrite my table here to make this better. Let's put in a half right here. What's a half squared? A half of a half? 4. Now we'll put in 1, we get 1. How about 3 halves? What's 3 halves squared? 9/4. Yep, 3 halves times 3 halves is 9/4. And then we put in our 2 and we get 4. Because these are the y coordinates I'm going to need for the trapezoidal rule. And keep in mind that the trapezoids actually would have straight sides. So the top of the trapezoids would go like there, 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 and there. So is my actual approximation going to be a little bit too big or a little bit too small?
Too big.
A little bit too big, because I'm actually going slightly above. Because it's concave up, I'm going to end up with straight lines that are above the curve, and my approximation will be slightly bigger than what it's supposed to be, than the actual integral value. So, but to actually use the trapezoidal rule now, let's just call it T for trapezoidal approximation. We're going to do 1/2 the height. What's our height again?
Half.
Half. So half times a half. Or you could do half divided by 2. That would be the same thing. Times. And then you're going to take your first y coordinate, which is 0, plus 2 times your second y coordinate, so 2 times 1/4.
There's no 1/2.
Plus 2 times 1, that's your third y coordinate. Plus 2 times 9/4. Plus your last y coordinate of 4. So you multiply every y coordinate by 2 except for the first one and the last one. Any questions about that? Hopefully you see the reasoning about it, about why we do that from the last example I gave you. Okay, so the trapezoidal approximation is approximately a half of a half is a fourth. 0 plus 2 times a fourth would be 2/4 or a half. Plus 2. 2 times 9/4, that's 18/4, which reduces to 9 halves. Plus 4. Let's do what's in parentheses first. Let's see. 1/2 plus 9 halves would be 10 halves. How much is 10 halves? 5. Plus 2 is 7. Plus 4 is 11. So 1/4 times 11 is 11/4, which is what? If I write that as a mixed number. And this answer is fine. What that is 2 3/4 also. Yeah. Or 2 3/4. Or 2.75. Okay? So that's the approximate answer. That's the approximate area under the curve. That's the approximate value of the integral from 0 to 2. Part B, use the concavity of the function to predict whether the approximation is an overestimate or an underestimate. We already talked about that. Because it's concave up, the tops of my trapezoids are actually above the curve, So I'm actually getting too much area. So for part B, this is an overestimate. I bet it's pretty close, even though it's an overestimate. We'll find out here in a minute, I think. Part C. Find the integral's exact value to check your answer. Different ways to do that. What are some ways we can find this exact value? Say that again. What? Could graph it on your calculator. Yep. But you know what? This is a pretty easy one. I'm going to do it without the calculator. Let's just do it right here. This is part C. Didn't have a calculator handy. It's not that tough because what's the integral of x squared?
1/3 x to the 3rd.
1/3 x to the 3rd, yeah. And we're going to plug in 2 and 0. If you plug in 2, 2 cubed is 8. 8 times a third is 8/3. Minus, plug in 0, you get 0. So you get an answer of 8/3. I would doubt that you could do it that fast in the calculator. That's faster. Which is 2 2/3. And our answer of 2 3/4. 2 3/4 is slightly bigger than 2 2/3. Right? If we look at it as a decimal, 2 3/4 is 2.75. And 2 2/3 is 2.6 repeating. So we can see that our answer was a slight overestimate. But not by much. Only about 1/10 of a unit, a square unit. Any questions about that?